What was the beep?
Okay, so today we're going to talk about quadratic story problems, specifically story problems involving projectiles today. So when I say projectile, that's basically something that's been thrown or catapulted or something like that. And we think of like when we throw a ball or something in the air. If we throw a ball in the air, what generally happens? Well, it kind of slows and then eventually it stops and then it starts coming back down, right? Well, what does that look like? That is a parabola. That's what happens when you graph a quadratic, right? So projectiles are actually going to be represented by a form of a quadratic equation. And there's actually a formula that goes with projectiles. It involves gravity and stuff like that. But basically, there's two forms we're going to use that talks about the different measurements. So you're going to see things in feet, and you're going to see things in meters. So the way it's going to be set up is you're going to have your height over a certain period of time, so of t. This is basically function notation, right? Height of the input of t is going to equal, if we're talking about feet, would be negative 16 feet per whatever the time is. Pretty much always seconds. Okay? And then it's going to be plus, I should use an uppercase T there for time. So it's going to be plus what we call our initial velocity times time. So when we say initial velocity, it'd be like v to the 0. So like v to the 0 is our initial velocity times time. And then that's also going to be plus our initial height. So height at our initial spot, so at 0. So that is our original equation there that describes how to find the what's happening. Oh, sorry, there should be a squared next to that. Negative 16t squared. So again, these different things here are representing different parts of an equation. So the height, this is our height over time. So height, or ht, is going to be height after some time. And then the v0t is our initial velocity. And then the HO, or H0, is our initial height. Okay? And the other form of that equation we're going to see is we're going to see h of t. If we're talking about meters, we're going to have negative 4.9 times t to the second power plus velocity plus height. Okay? So this number in front, the only number in here, this is our one thing that is always going to be constant between any equation, and that's because that's representing gravity. When we throw something, we're giving it some kind of push up, right? What's pulling it down? Gravity. Does gravity pull it up or down? It pulls it down, which means it needs to come down a negative direction, right? So this negative in front is what's going to eventually pull our object down back to Earth. And that's representing gravity. Okay? So let's look at an example. So this first one says a bolt falls off a plane at an altitude of 500 meters. So an initial height of 500 meters. If it falls off, its initial velocity would just be 0, right? It's just falling off a plane. So initial velocity is going to be just 0. Okay? How long will it take the bolt to reach the ground? So I want to see how long it will take in seconds for it to hit the ground. The height at the ground would have to be 0, right? So to set this problem up, I'm going to have 0, because that's the height of the ground, right? We're at 0. meters if we're on the ground, is equal to, and what I'm trying to solve for is the time, right? So I'm solving for a time here. So I don't know the t, so it's going to be negative 4.9 times t to the second power. And then my initial velocity. My initial velocity is 0, so plus 0 times t. And then my initial height is 500, so plus 500. Well, 0 times t is just going to be 0, right? So that term's going to go away. So I'm left with 0 is equal to negative 4.9 times t to the second power plus 500. Now I can solve this a couple of ways. I could use the quadratic formula. The b would technically be 0 here, right? So I could use the quadratic formula to solve it. Since there's only one variable here, I can also just solve it by doing square roots, right? So I could minus the 500 and square root. I'm going to do that because it takes less time. So minus 500 gives me negative 500 is equal to negative 4.9 t squared. And then I'd divide by negative 4.9 to each side. Okay, so negative 4.9 or negative 500 divided by negative 4.9 is 102.048 blah 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 blah. Okay, I'm going to keep that in here, and I'm going to have t squared is equal to, and I'm just going to write this as the fraction that it was here, so negative 500 over negative 4.9. And what I'm going to do now is I'm going to square root both sides. So to square root this answer that I already got, I'm going to push square root, and then there's an answer button right here. It's a second option, so I push second, and that just takes my previous answer, plugs it in my square root, and I push enter, and I get 10.1015. So that bolt that fell off that plane is going to hit the ground at about 10.0102 seconds. Okay, and that would be my answer. So I was able to figure that out. If a plane is 500 meters off the ground and just a little bolt falls off with an initial velocity of 0, it would take it about 10 seconds for it to hit the ground. Okay, let's look at another example. This one, a ball is thrown upward at a speed of 30 meters per second from an altitude of 20 meters. What is the maximum height of the ball? So again, I'm looking for the max. So if it's a parabola that looks like this, I'm looking for the max. Essentially, I'm looking for the vertex, right? I'm looking for where that ball is going to peak right there. So let's set up our equation. I don't know what the height is, so I'm going to have the height is equal to negative 4 point, is it 4? Yeah, meters. Negative 4.9, and I don't know the time, so t squared, and then plus 30t. So my initial velocity is 30, and then plus 20 is my initial height. So basically what I'm going to do to figure out my max height, I kind of need to know how long that's going to take. Well, if that is operating as like my x variable, the t is, right? That's my dependent variable. If I figure out what the x value is right here, or in other words, what the axis of symmetry is, I should be able to plug that in to figure out the maximum height, or the y value, which is h here. So I'm going to go ahead and figure out my axis of symmetry. Now remember, if it's in standard form like this, the easiest way to do that would be do x equals negative b over 2a. Well, a here is negative 4.9, b is 30. So if I did, and x is technically height here, right? So if I, well, t, actually, it would be t, sorry. T is equal to, let's see, negative 30 over 2 times negative 4.9 would be negative 9.8. Okay, which is the actual, or close to what the actual thing of gravity is here. And then I would divide those, and I'm going to get a not so nice number. Negative 30 divided by negative 9.8 is 3.06, blah, blah, blah. I want to keep it as close to that as I can, so when I plug it back in, I can plug in 30 divided by 9.8 each time, or I can just plug in this answer each time as I plug it back in. So I'm going to plug in, it's going to take about 3 seconds for it to get to its maximum height, so I got to plug in that for my t's here. So when I plug it back in, it'll be negative 4.9 times that answer, 3.06, blah, blah, blah. So I'm just going to put the answer in there, square it, and then plus 30 times my answer, and then plus 20. And I'm going to get 65.918. So my height at its maximum is going to be 65.918 or 2, or however you want to write that, meters. And that is my answer. Not too tough, right? So again, I did this first, and then I took that answer, which was around 3.06, and then I plugged that back in for t into the original one. So I had height was equal to negative 4.9 times 3.06-ish squared plus 30 times 3.06 plus 20, and I got 65.918. Okay, let's look at another one. So let's see. Let's look at this one. So this one, I have a height of an object after 5 seconds. Or what is the height of an object after 5 seconds if it is thrown upward at an initial velocity of 30 from a height of 200? So it wants to know what a specific height is at a specific time, and it gives me a velocity. So it's kind of giving me everything here except for the actual height. So this one's actually going to be set up pretty easy. So it's going to be height is going to equal, and it's going to be in meters, so negative 4.9, and it's going to be after 5 seconds. So I'm going to replace the t with 5. So 5 squared, and then the initial velocity is 30, so plus 30 times 5, and then the initial height is 200, so plus 200, and then I just solve that. I just plug that all into my calculator. So negative 4.9 times 5 squared plus 30 times 5 plus 200 is going to be 227.5. So the height is going to be 227.5 meters after 5 seconds. Okay? So that's how you do it if it gives you a specific time. You just replace the t with time. Okay? One more that I want to talk about real quick. And I'm just going to set it up. I won't actually solve it. So this problem, what is the height of an object after 2 seconds if thrown downward at initial velocity of 20 feet per second from a height of 175 feet? So the difference about this one is everything else has been talking about being thrown upward or just starting at a velocity of 0. This one is going to be thrown downward. So when we think about what's coming down, gravity, that initial number, those are negative numbers, right? Because it's pulling it down. If you're throwing down, that also means your initial velocity is going to be negative because you're going down to begin with. Okay? So to set this up, it's talking about the height. So height is going to equal, it's after 2 seconds. This one's about feet, so I'm going to use negative 16 at 2 seconds. So 2 squared, and then plus my initial velocity is 20 feet per second downward. So that means I'm not going to do a plus here. It's going to be a minus 20 times 2, and then the initial height would be 175. And then you would solve that by plugging it in, and you would get your height. And that is all you're doing with projectile motion. It's not too tough, right?